Hello, everyone, and welcome to today's Online Tech Talk. My name is Aditya Samant. I'm a database specialist solutions architect here at AWS, and I specialize in Amazon Aurora and Amazon RDS. For today's session, we will focus on Amazon RDS and all the new features and new innovations that we have added to the platform in year 2021 so far. So let's get started. Amazon Relational Database Services, or Amazon RDS, is a managed relational database platform offered by AWS. Amazon RDS gives you the choice of popular database engines, both commercial and open source, which means you can either choose from commercial engines like Microsoft SQL Server or Oracle, or either from MySQL, MariaDB, or Postgres from open source side. In addition, you can also use Amazon Aurora with either PostgreSQL or MySQL engine compatibility, giving you a wide selection of databases to choose from. The RDS platform frees you from the undifferentiated heavy lifting of monotonous tasks and helps you focus on the things that matter for your business, like query tuning and schema tuning, and to innovate features that give you more business value. RDS allows you to easily administer the platform without having to manually install or patch the databases, or having to worry about provisioning or procuring the underlying hardware. If you ever have been a DBA, you know how much work it is for planning that goes into like creating read replicas for additional scale. With RDS, scaling your database is just a few clicks away in your console or with your API or CLI, often with no downtime. RDS database takes advantage of the highly available and reliable database or an AWS infrastructure. And when you provision a multi-AZ database instance we synchronously replicate the data to a standby instance in a different availability zone. In addition, RDS also comes with out-of-the-box click-through options to automate tasks such as database backups, database snapshots, and automatic host replacements. Finally, RDS platform is highly secure, letting you to run databases in Amazon Virtual Private Cloud, which lets you isolate the database instance while allowing you to connect to existing IT infrastructures using a standard VPN. In addition to this RDS database instances, we also offered multi-layer encryption in transit and at rest. At Amazon, we are a customer-obsessed organization, which means that 90% of our services, including RDS, are based on direct customer feedback. This also extends to the features we add to these services. We have various mechanisms to receive this feedback directly from our customers, and our customers ask us to innovate in a broad spectrum of categories. So what I'd like to do here then is to go through these categories and show you the new features we have added to each category. So first and foremost, it's choice. As I said at the beginning of this session, you have the widest choice of relational databases to choose from. Our customers also want choice as to where they deploy their database instance, which part of the world, or even within their data center. So we have made even more choices available this year in that category. In addition, we are also making more choices available in terms of where you can deploy the database, so the database can still stay closer to your customers. We realize that customers have different needs for different versions and features for their databases. So we are making even more versions available. So let's talk about our regional infrastructure first. At AWS, we build our global infrastructure using regions. Regions are geographically isolated physical locations, and they are made up of multiple availability zones, or AZs for short. AZs are essentially fault domains of each other, and they are interconnected with ultra-low latency, redundant network. Including the new regions we launched in late 2020, as of today in 2021, we have 25 regions and 80 AZs across the globe. We also offer local zones, which are extensions of these global regions. We deploy these local zones near to large populations, industries, and IT centers. This allows our customers to run applications that need single-digit millisecond latency closer to end users in a specific geography. In May 2021, we made Boston, Miami, and Houston local zones available, which are child zones of US East Virginia region. We also announced in March that in Japan, the Osaka local region now has 3 availability zones and is available to deploy all resources. We also hear from some of our customers that they would like to run RDS in their own data centers. The reason for that, well, there are a couple of reasons. First reason is data residency requirement. You may have some regulatory reasons to keep and run the databases as close to regulated regions as possible. For example, keeping data local in the country or even in your own data center. So this could be a regulatory reason, or it could be a contractual reason, or it could be driven by your IT regulations or requirements. Regardless of what that reason is, there is sometimes need to keep the RDS instances in your data center. Other reasons we see is the need for low latency responses in certain types of applications, like IoT use cases, manufacturing systems, or medical diagnostic systems. So far, these type of special use cases, we launched RDS Outposts. This gives you the ability to run RDS directly in your data center with the familiar RDS UI, CLI, and automations. This year, we added Microsoft SQL Server to the supported database engines that can run on RDS on Outposts. In addition, this year, we also launched the ability for our customers to bring their own IPs to RDS Outposts. This capability allows customers to assign addresses or IP addresses from your local network to the services like RDS on Outposts. This makes it easier to access your Amazon RDS databases from your local network using your own IPs. So let's look at some of the capabilities and benefits of RDS on Outposts real quick. The first one is the most obvious, the unified UI. Whether you're using RDS on Outposts or RDS in any other AWS region, you get the same familiar UI that you're used to on your AWS console. There is no special UI designed for RDS on Outposts. RDS on Outposts also provides you the automation and functionality that you have come to expect, like easy database provisioning, automated backups, parameter groups, and more. We support both open source databases on RDS Outposts, which is MySQL and Postgres. For MySQL, we support MySQL 8.0. For PostgreSQL, we support 12 and 13 both. In addition, we now also support Microsoft SQL Server versions 2016, 2017, and 2019. Another important thing that customers want when it comes to choice is major and minor version releases of the databases. This is important for a variety of reasons. One reason, obviously, is to stay up to date with the latest features. These features are made available in the latest version of the databases. Another reason is to stay up to date with the latest security fixes. Customers also have requirements to have multiple versions available of the same database engine at the same time. And this could be to address specific features that they want to use, or to address security patches, or sometimes to make sure that they have all the right bug fixes, and overall to get the best performance from their database software. So keeping that in mind, this year we have released new versions for both major and minor versions, and new feature capabilities for all database engines that are supported on RDS. So let's begin with PostgreSQL. This year we announced support for PostgreSQL 13 major version for RDS. PostgreSQL 13 brings improved functionality and performance enhancements such as deduplication of B-tree index entries, improved performance for queries that use partition tables, incremental sorting to accelerate data sorts, parallel processing of indexes with vacuum command, more ways to monitor activity within a PostgreSQL database, and new security capabilities, and much, much more. This release also adds supports for bool PL Perl, which simplifies writing Perl procedures. You can also consume time series data with improved data ingestion rates. We also added support for various new minor versions you see listed on the screen, ranging from Postgres 9 to Postgres 12. We also added support for two new extensions this year, pgcron, which enables you to schedule jobs by letting you use cron syntax directly from SQL commands, and another extension, pgbigam, for faster full-text search of languages that require multi-byte character sets such as Japanese, Chinese, and Korean. It also lets you create bgram indexes for faster full-text search of text encoded with multi-byte characters. So moving on to MySQL. For MySQL, we now support new minor versions for all three major versions. These new minor versions are 5.6.51, 5.7.33, and 8.0.23. We are also very close to launching 5.7.34 and 8.0.24. So that's a little bit of glimpse of the future for y'all. We also announced support for replication filtering for RDS MySQL. This feature support allows you to select or ignore tables or even entire databases, which will be part of your read replica for that RDS MySQL instance. You can also take advantage of replication filtering by using replication do DB, replication do table, or ignore table parameters in the parameter group. Replication filtering is a great feature that can reduce the size of your read replicas by excluding unnecessary databases or tables. Or it can benefit security compliance by excluding databases or tables from a replica. Customers can use replication filtering to create replicas tailored to their specific use cases like analytics or sharding, or to create replicas with different databases or tables in different AWS regions. In addition to this, we announced the support for major version rollback protection for MySQL on RDS, which means when you upgrade from RDS MySQL 5.7 to MySQL 8.0, in addition to pre-upgrade checks, we also automatically roll back to running state of MySQL 5.7 if for some reason the upgrade fails. The rollback protection is automatically enabled for all of the customers. Let's move on to MariaDB. For MariaDB, we announced the support for 10.5.8 minor version, and we are very close to releasing a few more minor versions as you see on the screen. Similar to MySQL, we also announced support for replication filtering for MariaDB on RDS with similar benefits as MySQL. We also announced support for North California, Canada, Sao Paulo, and London regions for MariaDB, where you can launch MariaDB on RDS. For SQL Server on RDS, we have released a slew of new features this year. First, we announced support for extended events, which lets you use the lightweight event-based performance monitor system that can be used to monitor and troubleshoot problems in SQL Server. We also announced support for R5D and M5D instance types, with TempDB configured to use local instance storage. TempDB is used for sorting and other temp usage in SQL Server. Workloads that have heavy dependence on TempDB can greatly benefit from low latency local TempDB storage. By placing TempDB data files and log files locally, you can achieve lower read and write latencies when compared to the standard EBS-based offerings. R5D and M5D instance types also offer up to 3,600 gigabytes of NVMe SSD-based instance storage optimized for low latency, very high random I/O performance, and high sequential read throughput. When provisioning either instance type, Amazon RDS for SQL Server automatically places TempDB files on locally attached NVMe disks, achieving low storage latencies and improving performance for certain workloads by up to 30% even. So let's talk about Oracle. Oracle for RDS now supports the October 2020 patch set updates, or PSU, for Oracle Database 11.2.04 Enterprise Edition. In addition, RDS for Oracle also allows you to set system events using the rdsadmin.rdsadminutil.set system event procedure. We also announced support for the January 2021 release update, or RU, for Oracle Database 12.2, 18c, and 19c. We announced support for 20.2 version of Oracle Application Express, or APEX, for 12.1, 12.2, 18c, and 19c versions of Oracle Database. Using APEX, developers can build applications entirely within their web browser. Finally, we announced support for Oracle Management Agent, OMA, version 13.4 for Oracle Enterprise Manager, OEM Cloud Control, 13c, Release 4, Update 9. OEM 13c offers web-based tools to monitor and manage your Oracle databases. We install OMA, which then communicates with your OMS to provide monitoring information. Customers running OMS 13.4 can now manage databases by installing OMA 13.4. Okay, so that was quite a bit in terms of version support and features. In addition to engine features, our customers also want a database that is secure and compliant. Security is and always will be our top priority at AWS. And we continue to invest and innovate in the security and compliance area so your application can be compliant with various regulations. So let's take a look at those innovations. We have added a few new features this year that enhance RDS platform's ability to comply with regulated workloads. If you have ever worked with regulated workloads, then the compliance regime requires you, let's say this compliance regime requires you to use FIPS 140-2 validated endpoints. You will be happy to know that RDS Data API now supports FIPS 140-2 validated endpoints. You can currently use RDS Data API with Aurora Serverless v1 to issue SQL commands via HTTPS API endpoints. We also announced support for encrypted cross-region automated backups. This support is now added to Oracle RDS and PostgreSQL RDS. For Oracle, the support is added to version 12.1 and higher for all editions of Oracle. For PostgreSQL, the support is added from version 9.06 and higher. You can now use this feature between US East 1 and US West 2, EU Central 1 and EU West 1, and AP Northeast 1 and AP Northeast 3 regions. So if you have a regulated workload where compliance requires cross-region backups to be encrypted, now you can. Okay, so next area or next category where customer asks us to innovate is durability and availability. So we started by talking about choice and understanding where databases can be deployed and its performance characteristics. We discussed about security and compliance. So once the database is deployed and serving applications and serving queries, customers want to make sure that data is durable and we are able to recover the database in case of unpleasant events like hardware failure on a system or a system crash. Also, customers want the ability to stay highly available. To that end, RDS runs on highly available infrastructure and is able to set up multi-AZ HA with a single click of a button. Setting highly available databases is a fairly complex task, as I can tell from my own experience as a DBA. And it's even more challenging as the application starts to scale. So let's look at some of the enhancements we have made in this category this year so far. So cross-region automated backups is a very common ask from our customers. And customers used to make this work by custom scripts, Lambda functions, etc., etc., etc. The main use case for cross-region backup is simple. Ability to failover to a separate region and create and restore a database in that region quickly in an event of primary region failure. So essentially a DR type scenario. So there has been a customer demand for this type of managed DR feature for some time. Most of our new features come from customer demand, so we made this feature available directly via RDS automation, which automatically copies the snapshots and transaction logs to another region With cross-region backup copies, you can even set up separate retention periods for these backups. So we have had several engines support cross-region backups, and this year we added Microsoft SQL Server support as well on RDS. This support is for all editions of supported SQL Server on RDS. Now you can issue point-in-time restores directly from a target region in an event of a disaster. Let's touch on the RDS availability enhancements that we have done in 2021 so far. RDS platform offers RDS events, which notify in case of certain operational events such as database start, database stop, instance failure, etc. Customers can use these events for notifying and taking appropriate actions in the event of failures, for example. We have added new failover events that can be consumed for notification and further action for RDS PostgreSQL this year. Starting 2021, we also support always-on availability groups for multi-AZ configurations for RDS SQL Server on Standard Edition. Earlier, you either had to use an Enterprise Edition for availability group support, or for Standard Edition, if you had to use Standard Edition, we would just use database mirroring in the backend. So if you're using Standard Edition now, you can take advantage of always-on availability groups. As you can imagine, customers also expect us to innovate in the price performance category and provide ways to optimize the RDS cost structure. So let's see what type of innovations we have done in this area. Last year, we made Graviton 2 instances available for RDS. And this year, we are making even more regions available where you can deploy Graviton 2 based RDS instances. The new regions are North California, Sao Paulo, and London. AWS Graviton processors are custom built by AWS using 64-bit ARM Neoverse cores. Our internal benchmarks have shown that we see up to 35% performance improvement and up to 52% price performance improvement when compared to similarly configured M5 instances. So here's an example of the benchmark we did internally on this slide. If you look at the graph, you can see orders per minute on y-axis and number of threads on x-axis. So as we increase the number of threads, you can see that M516 X large instance is not able to scale beyond 256 threads. But the M6G extra large keeps going and is able to scale much better. Same can be seen on the graph on the right, where we are doing the same benchmark on M5 large instances this time versus M6G large instance class. Again, M6G Graviton 2 based instance, we can see that it comes out on the top end of the Graviton instances. And the Graviton 2 instance shines in this case as well, and it's able to scale much better with more thread and concurrency. Finally, our customers also want us to innovate in the ease of use category. So let's see what innovations we have done in this category so far in 2021. So before jumping into the new features, I quickly wanted to talk about RDS Proxy. RDS Proxy is a fully managed and scalable service that makes your applications more scalable, more reliable, and more secure. RDS Proxy does these things by offering connection pooling. It helps with seamless failovers by removing dependency on cached and possibly stale DNS entries at different layers, and by integrating with Secrets Manager and eliminating need for manually managing password complexity, rotation, etc. So let's quickly see how connection pooling works with RDS Proxy. Your application will connect to RDS Proxy, and then RDS Proxy will in turn connect to the backend database and the backend database instance. RDS Proxy can intelligently make decisions and reuse connections appropriately, thus eliminating excessive database connections. Creating a new connection every time, let's say your application is creating new connection every time, which is very CPU intensive and memory intensive task. RDS Proxy helps by reducing the need for excessive connection creation to the database directly. This is done by reusing the connections, which is called as connection multiplexing. This helps you in situations where application may need to scale suddenly and needs several connections. To respond to a new product launch, for example, these are the type of hyperscaling events that we see several times with our customer applications. RDS Proxy also makes the failover events much faster and much more predictable. So as seen in this picture, the application connects to the proxy endpoint, so it doesn't know about the database in the backend at all. And when the failover happens, the proxy can hold on to this connection. And once the failover is done, the connections are released to the new database instance, making failover much more seamless. So we have done a bit of benchmarking with RDS Proxy internally. And as you can see in this graph, here the orange line is a direct connection, as in without proxy, using MariaDB MySQL driver to an Aurora MySQL instance. And then the blue line is when using proxy. So you can see that the failover times are much, much better with the proxy, up to 66% better. So clearly, RDS Proxy is a great choice for seamless failovers. So RDS Proxy has been around for some time now, but we mainly supported writer instance with RDS Proxy. This year, we also launched the ability for RDS Proxy to talk to reader instances as well. This capability is currently only supported for Amazon Aurora, but we plan to expand this to other open source databases as well. So what this means is that if you have read-only workloads that need to talk to read replica, you can use RDS Proxy read endpoint, which will let you talk to the read replica while taking advantage of the proxy features like connection pooling. Another new capability we added to RDS Proxy this year is the ability to use RDS Proxy from a different VPC than the one where it was initially created. So imagine this scenario as shown on the slide. On the left-hand side, you have an application in a VPC A, and your database is in VPC B. Your RDS Proxy is also in VPC B because RDS Proxy creates the primary endpoint in the underlying database VPC. Until now, your app in VPC A couldn't use RDS Proxy endpoint in VPC B. But with the new launch, you can create an additional proxy endpoint in VPC A, which in turn connects to databases in the backend. So this is a pretty cool feature that is available now. This year, we also added the capability for RDS PostgreSQL to call Lambda functions. We have had this capability for other databases like Aurora for a while, but now we have extended it to RDS PostgreSQL as well. With this ability, you can call a Lambda function directly from PostgreSQL, RDS PostgreSQL. For example, you could create a trigger every time a new row is inserted in orders table that calls a Lambda function that reads the new row and takes further actions in other parts of the application, for example. You can call Lambda functions by using AWS Lambda.invoke function directly from RDS PostgreSQL query. So this concludes our tech talk, and we were able to cover a bunch of areas and various features in a short amount of time. Thank you so much for taking the time and giving us the opportunity to talk to you about the new and exciting RDS innovations. As always, you can always reach to your AWS teams, and we'll be more than happy to help you if you have any follow-up questions. So don't hesitate to reach out. Have a great rest of your day. Thank you.